and I'll do just a quick introduction of our company. Most of you, I recognize your names, so you've seen us before. I am Bill Murphy. I am the civil engineer for ASP Enterprises, Quick Supply Company, Bowman Construction Supply, and Cascade Geosynthetics. So we're all the way from Illinois out to Oregon and Washington, and we're the upper Midwest and across the Rockies there. And I'm the civil engineer that does the technical support for all of our sales folks. We have 40 some sales professionals now. It says 27, but we've got a lot more than that, well over 12,000 customers. And the 40 plus years is each of those businesses has been around for a very long time. And we have a whole lot of experience under our belt. There's the map that I already explained where we're at. I'm currently sitting in southern Iowa, not far from the Missouri border, but I cover all of those states. Haven't been traveling much due to COVID. In fact, I haven't traveled at all since last February, but I do a lot of virtual meetings. We're focused on our earth anchors today, but we use those to support our erosion and sediment control market, as well as some of our other markets. We have some road projects, roadside stabilization projects, some creative stormwater projects we get into. Some of our locations actually deal in hardscapes. I focus primarily on stormwater management and innovative solutions involved with stormwater and erosion control. And we are blessed with great logistics. We have fleets of trucks, very good warehouse staff and drivers, and we have a lot of inside and outside storage at all of our locations. What that matters to you is we're kind of a one-stop shop for a lot of different construction site supply products. So we are a distributor. We do not manufacture anything. And even though I'm a licensed professional civil engineer in Iowa, I do not compete with engineers. I help engineers and landscape architects with their designs, work with a lot of city, county, state, and federal government agencies. And I also work with contractors to train them on new solutions, to help facilitate pre-construction meetings. And when the pandemic allows, I'm often on site, hands-on, making sure people get past that learning curve. So anything new to them, they pick it up quickly. It makes everybody more efficient and more successful. So here's the contact information for each of our locations. I'll show this again at the end of Andy's presentation, but you know, it's the modern age, just Google us. With that, I want to introduce Andy, and I'm going to hand over the controls while I read a little bit of his bio. From what I know about Andy, and the couple of you that got on here early will know that I went ahead and had him verify it all with me, that he has a business degree from Washington State University. He's been in the construction and erosion control industry for 30 years, and he's worked with a number of different manufacturers and distributors, which is what I do. And he got really involved primarily with percussion-driven earth anchors about 5 years ago. He resides in Atlanta right now, so he's a little warmer than I am, but he covers the entire country, and I'll let him talk a little bit more about that. So everyone, please use the Q&A feature, and we'll get to those towards the end. But with that, I welcome Andy Constantine.
All right. Thank you, Bill. Thank you all for joining us. You might be looking at this picture or these 8 pictures on our introduction slide. I'm going to talk about similar type projects. None of them are specifically those projects, but you'll recognize some of the applications as we go along. Okay, all right.
You're on the who we are.
I'll tell you a little bit about Platipus Anchors. We started about 40 years ago in the UK, as 38 years ago or so. But our owner became a manufacturer of what's now known as percussion-driven earth anchors. He came up with some ideas that he thought some of the early earth anchors could benefit from, move production around a little bit, still mostly European, until he opened up the US operation close to 20 years ago. He had a distribution facility before that for maybe 10 years, but really got into the US 20 years ago. And we distribute worldwide, as you can see in this slide, mostly through select distribution outlets. We're not everybody's commodity product, but we certainly are a solutions provider. All right, so I guess I gotta. It delayed me. Sorry, guys.
Yeah, you're clicking pretty fast there through a couple of slides.
Well, I clicked and it didn't go.
Yeah,
And so I
let
clicked it a second time.
it might take a couple seconds every now and then. I have nothing else running, but you shouldn't be more than a couple second delay.
Okay. All right, this is the slide we wanted. So this is a really good animation. You can kind of get an idea of different applications for percussion-driven earth anchors. You might think of the guy wiring that you see on the utility poles. In the UK and lots of Europe, over in China and other places, they do use percussion-driven earth anchors for tying down or guy wiring the telephone poles. In the US, not so much. They use a helical anchor for that because they already use a drill to put the telephone poles in. So they just basically take the telephone pole off that, or they take the drill off of their big machine that they have there and put a helical anchor on it and screw that in the ground and then tie off to that. But other places you'll see a percussion-driven earth anchor is vineyards and agricultural. You might see them occasionally. We're probably the largest solutions provider for buoyancy control with pipe. Work with ADS and several of the other large pipe manufacturers to make a buoyancy control kit. Then you'll see us in landscaping for root ball tying down. We don't typically do a guy wire on the trees. Most of ours is below grade. But then what we're going to talk about today are anchor reinforced grid solutions. That's slope stability predominantly, some erosion control, and then some civil engineering applications, either temporary or permanent walls. All right, so what is a percussion-driven earth anchor? Percussion-driven earth anchor is a unique, versatile anchoring system suitable for most soil conditions. We offer an earth anchor that can be driven from ground level using portable equipment and can be operational and proof tested immediately. And it's grout free, and it doesn't disturb the soil when you're putting it in. There's a little disturbance, you know, as you're driving an anchor in, but you'll see in some of our installations coming up that it doesn't take a whole lot of work on the ground there to get things moving. Okay, I'm going to show you quite a few animations in this presentation here. I guess the first thing I want to point out is that these animations are available on YouTube. If any of you want to go back and look at them later, or you want to share them with somebody, you can go to Platipus US, as in United States, and you'll find probably about 7 or 8 different animated videos. If you dig a little bit deeper, there's probably 40 or 50 worldwide and videos on YouTube. We've got a group out of Switzerland, another one out of Australia that are really, they put a lot of good videos online as well. But anyhow, what I'm going to do with this first animation is just kind of show you how an earth anchor works, the installation process, and then removal of the drive rod, and then activating that anchor by pulling up on the tendon. This tendon can be wire, it can be all thread rod, but what we're going to do is basically create a bulb of pressure down in the soil. This whole principle of installation and loading the anchor is the same from our smallest anchor all the way up to our largest anchor. You got to drive it. You remove the drive steel, then you pull back on the tendon or all thread rod and activate the load. What we're really pulling against is that bulb of pressure. We're not pulling against the anchor itself. Well, you know, in principle, we're pulling against the anchor, but most of the strength comes from that consolidated mass of soil that's directly on top of the anchor at this point. Okay, before we talk too much about anchors though, the different styles of anchors, I do want to talk about some of the variables that are involved in designing or selection of an anchor. The main one being, you know, what's site access like? Can they get a machine in there? Can they only do it by hand? Is there limitations to where the anchor can go? Sometimes you might have utilities behind a wall or an excavation, or you might have somebody's property line and they just don't want you to have an anchor, even though it's 10 foot deep on their side of their property. So we run into this a lot on like rail lines and that type of thing. You cannot put anything into a right of way of a rail line. They don't care if it's 20 foot deep. You can't cross their line. So the other variables, as you see on the slide here, are really, what are the soils like? What are we dealing with? What size anchor can we even put in that area? And then, you know, what kind of connection do you have to whatever that device is that you're tying down or you're locking off to? Sometimes it's nothing more than a stainless steel plate. Other times it's got to be tied off to another tendon. So I'm going to jump right into our different anchoring systems. There's predominantly two categories. One is a smaller anchor that's streamlined with a chisel nose. It's narrow. It's easy to drive. It's what we call our stealth anchor series. And the stealth anchor has 4 models within it. The smallest being about the size of your thumb, and it mostly used for tie down applications. Maybe you're tying down a geotextile, an erosion control matting, even a permanent HPTRM. A lot of times the loads on that are somewhere between, say, 200 and up to 550 pounds. The wire tendon connected on that can take a little higher loads than that, but because the wire's fairly small, it's a 3 millimeter diameter wire, you can't get a good grip on it with the wedge grip that basically locks it in place. So we rate our smallest stealth anchor at 550 pounds, and our largest stealth anchor, which where that one's the size of a thumb, the smallest one, the largest stealth anchor, our S8, is about the size of maybe a man's size 8.5 or 9 shoe. So it's about 10 inches long and 4 inches wide or so. And that one can take loads up to, say, 15 or 16,000 pounds. Really, the main thing behind the stealth series of anchors, though, is for the most part, they can be installed using handheld equipment. When you start getting deeper than, say, 9 or 10 feet, you're probably looking at machine-mounted hammer, but a lot of the stealth anchors are only installed between, say, 4.5 to, maybe 8 or 9 feet. That brings up our bat anchor range, and the bat anchor is a flatter, larger anchor designed to create more loads, either because you need more loads in granular soils or you're in clays. You're going to learn a little bit later in the presentation that the clays don't behave quite as well as granular soils do. So a lot of times in clays, we jump right to a bat anchor. But the main thing to know here is, these anchors are our smallest ones, maybe 4.5 inches wide by 11, 12 inches. Really our workhorse bat anchor is a B6, and it's rated up to 44,000 pound ultimate capacity. That's really the mechanical capacity of the anchor itself. But that B6 is maybe about the size of an iPad Pro. And then our largest bat anchor is a B10 at about 21 inches wide or long and about 13 inches wide. Maybe think of like your desktop monitor that you might be looking at right now. That's about the size of mine. So that's the largest anchor we make. What you do need to know about these, again, as I mentioned, the smallest bat anchor is rated up to 44,000 pounds, and the largest bat anchor is rated for 44,000 pounds. Really, the soils are going to dictate which model we choose, and we're always going to choose the one that's easiest to install and, of course, the most economical or lowest cost. As well as the different sizes of anchors, there's also different materials that make these anchors. Depending on the application, is it temporary, is it for 10 years, or is it in a caustic type environment, or is it in the ocean where you know things corrode quite quickly? We make different anchors out of different materials, starting with an aluminum alloy. Generally, and most neutral soils, you can plan on aluminum alloy design life somewhere in the, say 40-year range or so. Most of the time we talk about 50, with the aluminum, but we can hard anodize an aluminum and get another, say 15 years out of it, up to about 60 years, or we can switch to a cast iron. The cast irons are all hot dip galvanized. They'll take you to about 60 years. And then if you really want something that's 100-year true life, we'll be looking at an aluminum bronze anchor. You might get into a little bit higher cost, but we use these in the ocean quite commonly, and they're not necessarily on the shelf, but we have pretty good access to them. It might take another 30 days to get them, but they are available. Along with the materials that make up the anchor are the accessories that go along with them. So in a temporary environment, you might see a galvanized steel tendon. We almost predominantly use nothing but the grade 316 stainless steel. That's a marine grade stainless steel. And you can see that their stainless steel tendon will take you out to at least 100 years, even more than 120 years. Then the other items that go along with that would be your load plates and your wedge grips. That's the device that locks off the load. And outside of that, you could be on all thread rod. Most of your all thread rod is galvanized. When we're on temporary projects, we might use a black steel, but for the most part, most of the anchoring configurations that you'll see from us are galvanized rod or stainless steel, as mentioned previously. So again, we ask a lot of questions going in when we start talking to either an engineer or a contractor or an agency that's dealing with an anchor. One important item, other than its longevity, then of course, is how does it tie off, or what is the top accessory? Again, I mentioned stainless steel several times. All our load plates are pretty much a grade 3, they're grade 304 stainless steel. We do make an HDPE plate, one that's used quite commonly in the landfill business, and then also with a soft gabion that you see in the center top picture. We also make brass for ornamental type plates. And then you can see the dish plates down below. The reason we like a dish plate, especially on like an ACB block in the bottom left, is used with a recessed wedge grip. By the time you cut that tendon off, you pretty much could run a vehicle over the top of it and never touch that wedge grip, so you don't have to worry about damage. The other thing that we see on these ACBs is a tripping hazard. Sometimes maintenance folks will get on there, or even kids playing on it. So one thing that you need to know about these plates and wedge grips and stuff is nothing is standard. We custom make everything. We don't have one set component that we use across multiple applications. It's really we build anchors to the spec or to the client's needs. So design and support. What we see here, we do have a geotech that's on staff. I'll be 100% transparent with you. He is an English gentleman. He's a young geotech, maybe 25 years old or so. Lives in London and does a fantastic job. He's very progressive, very smart, and does a very good job for us. He's got a couple geotechs under him that are starting to build a pretty good group for us. So when we do talk about design, typically, you know, you have some standard that you design by. For bridges, you know, of course, there's a bridge standard, or for road pavement, there's a standard. When it comes to percussion-driven earth anchors, there's not really a standard out there for design. There is a earth anchoring standard that Federal Highway Administration put out maybe 25 years ago or so, but it's predominantly geared towards like a soil grouted nail. What you might see like the Dewey Dag system or some of the others, if some of you engineers on the call here have designed with soil nails. The difference between those and a percussion-driven earth anchor, and the reason why we can't just adopt their design standard is, you know, they're dealing with bond length and what they call skin friction, which is the action between the soil and the skin of the grout itself. So what we can do though is, if you are, you know, like we just did one recently for Texas DOT, and they had to modify their design standards to include a percussion-driven earth anchor. That has nothing to do with bond length and that type of thing. But they were able to take their standard that the state had adopted and work with it. So we can do that for you if that's a requirement. What we'd rather do is design by either sending an anchor out. You see this picture on the top right here, and actually doing a soil test. We basically put an anchor in the ground and we pull it to failure. So we can basically back calculate what the strength of the soils are and what the performance of any of our anchors are from that one test. So in lieu of actually doing a test on site, we can also design by theory, which I'm going to talk about in these next two slides. So if we're in granular soils, you pretty much can think about Terzagh's equation. Some of you engineers on the call here are probably familiar with Terzagh's shallow foundation calculations that he came up with, I want to say 60 or 70 years ago. They're commonly taught still, commonly used. Basically, we modify a simplified version of Terzagh's equation to basically model a percussion-driven earth anchor. Now, our foundation isn't necessarily in the same direction as Terzaghi meant for it to be. We'll actually turn it up on side, but it still uses the same principles behind the design. So with that, that works great in granular soils. What we know about granular soils, what we've learned in the 40 years we've been making anchors and sending them out on site, is granular soils are really nice to work with when you're dealing with a percussion-driven earth anchor. You can see the frustum cone, or that bulb of pressure in this slide, is very wide. What we find is as you drive the anchor in and you go to pull back on it, it activates extremely quickly, and that cone of that pressurized zone spreads quite fast. In clay soils, it's a little bit different, and there's a totally different set of equations that Alex Skimpton came up with a little bit later. These came out maybe in the 80s or 90s, I believe. But nonetheless, he looks more at the undrained shear stress or shear strength of the soils to do a similar type of foundation equation to basically tell you how much foundation you need. Again, we use the same theory. We can lay it on its side or upside down or whatever it is. It works the same as long as you're dealing with soils. And what we found is there's a narrower cone of pressure in clays, and it'll actually shear through much quicker because you don't get the type of interlock that you get with aggregates. But you can still design with it using, say, a larger anchor, or you know, making some other provisions to account for those clay soils that are more elastic. So. If any of you have ever been on our website, or if you've ever been involved in, say, Slide by Rock Science, or the Slope W software, or some of the other softwares that are available out there, a lot of times you'll get to a point where you'll know how much load you need on your slope to stabilize it, and you can lay a pattern of anchors out. We like a 4 foot by 4 foot pattern because it's easy and keeps our, we always like to target our stealth series so we can keep costs down, make the drive easy and easy to handle. You know, to give you some idea, an engineer may come in and run his slope stability software and come back and say, hey, I need 400,000 pounds and I want to spread that load out with 100 anchors on a 5 foot grid pattern. So he'll go back and do his calculations. He'll do his 400,000 divided by 100, and he'll come up with 4,000 pounds per anchor. That's probably more than likely his working load because that's what the software told him. And now he needs to figure out which anchor will work and those soils he has to give him those 4,000 pounds. That's where this anchor load indicator comes in. He can go online. You do have to register to use it. It's not for just anybody. You know, we'd really like it to be used by geotechs, civils doing this type of design, or a structural engineer. But he'll get on and he'll plug in his soil parameters and a granular soil, and then he will select an anchor. He'll, in granular soils, he'll need to tell us what the overburden is as well. That's the height of soil above the anchor where it presides after it's loaded and locked. And then he'll plug in that fourth item down. See that says S, I think it says S8, can't read it that well. Might say S6, but he can choose which anchor he wants to plug in there. So if he puts in an S6 and it tells him a number, this is in kilonewtons. I didn't convert this stuff over, but that's about probably 14,000 pounds or so with an S8. If he were to plug in an S6, it might be, say, 10,000 pounds, or it could be 7,000 pounds. But anyhow, he does have to select which anchor he wants to do his analysis on. And this will pretty much predict what the ultimate capacity of the anchor is in those given soils. So that is available. You can jump online and take a look at that if you need to. All right, so this is what an actual soil test looks like. This is a lot of times if we're building a wall, we'll go up to the top of the structure where the wall is going to be, and we can drive an anchor straight down at the elevation or the strata where that anchor head will preside after you drive it and load lock it. So what he's going to do here is drive that anchor. He's going to put one of our load jacks with a load gauge on it, and he's going to go ahead and pull it to failure. So what failure looks like is where that graph flattens out, and I'm going to show it to you on this animation. It's where the graph flattens out and then sometimes even not only levels off, but starts to decline. So early on in the test, that graph will climb extremely fast as the anchor's turning. What you're getting is a lot of extension. You're pulling that tendon, and a lot of it's coming out towards you. And as you get up to the top of the graph, he's reaching the ultimate capacity of the soil. It's not going to pull out as much. It might only get like an inch or so every few strokes of the jack. And then eventually it's going to level out, as I said, and then it's going to fall off. Sometimes you'll even break the wire tendon or the steel tendon at that point. But what this tells us, then, we can actually go back and back calculate with the size of the anchor and the other items that are involved in this test and get a pretty good reading of what those soils are. So in lieu of having a good soils report, we actually can send an anchor out, and something we do quite commonly. We usually do it free of charge even, and loan them the tools to run the test. All right, so technical design. This is a picture of Elliot. He's our geotech, and he's really good at getting online, doing video conferencing, right direct with the design engineer. He'll do a step-by-step guidance. He can do software training. He's really good on both slope W and slide. He can figure out pretty much the others pretty easy. We'll do feasibility assessments. We can do a design review if it's one of your first ones or your 10th one, whatever it is. It's quite common that a lot of the engineers we work with will send us over their design and ask us, you know, hey, can I do something to take some cost out of this? Or can we do something to increase my factor of safety? I'm not able to figure this one out. And so we do have that available. It's always free of charge, and they're always ready to go to work for us. The only disadvantage we have with these guys is they're 5 hours ahead of us. So if you're on the West Coast, that's going to be, you know, maybe a 7 a.m. call for you, because he's 9 hours ahead of you. No, 8 hours ahead of you. All right, so one thing that our geotechnical group does for us is provide conceptual proposals. With a conceptual proposal, they'll typically run the analysis for slope stability or wall stability using this third-party software. We don't create our own software. Again, we use mostly Slide, but they'll run the calculations. He'll select an anchor, put it on what he calls an anchor scheme. We'll create a specification for you, and we'll give you a quotation for it, show you, you know, what the system will cost, less the labor to install it and shipping and all that stuff. So this is what a conceptual proposal looks like. Usually the ones we do for slope stability, a lot of times, and we do this, we've done 3 or 4 of them now with ASP, where they'll give us a cross section and a soils report and tell us what the goal is, and we'll have the geotechnical group run the analysis and create a 14, 15, even 20-page report that looks like the one on the far left. He'll usually put some pictures in that are similar to that type of construction. They'll go in and do a full summary based on the information provided. That would be the soil parameters and you know, the cross section itself, what access is like, and that type of thing. And then he'll actually show the slope analysis with and without the anchors in it, and the factors of safety that were gained, and then of course give you the solution. He'll also, you know, if, like I say, if you have a tie down application and you're just, you know, having a hard time trying to figure out how to tie that thing down with a dead man or whatever, it's very common that we'll take a look at those and come back with a mini report. It won't be 20 pages, but it's something that he can certainly take a look at for us and get you something back. This is what one of his slope analysis solutions would look like. When he designs this, the slope analysis software won't necessarily draw the anchors. They're really geared again towards soil nailing, but we've figured out how to manipulate their software to also model a tipping plate anchor or a percussion-driven anchor. What you do is you actually shorten that bond length down to a few inches. So instead of having a 30-foot soil nail, grouted soil nail with 10-foot bonded strength, you basically can do the same thing with a 20 or 30-foot percussion-driven earth anchor with a bonded length of, say, 4 inches or 5 inches, and it will model something similar for you. So he does take into account all the site parameters, looking at the perched water, the water table, live loads involved in a slope, and you know, as I mentioned, pretty much create you a scheme that gives you a factor of safety with the anchor pattern, depth, and loads that he develops there. All right, we're going to get into the quick part of the presentation now. I'm going to quit talking so much and show a lot of pictures. Where the way this is set up is we'll show you an animation. The animation will run for 20, 30 seconds, something like that. And then I'm going to give you 2 or 3 project spotlights that correlate with that particular animation. And these pictures that you see here, some of them are in here as well.
So when you click, Andy, just remember to give it a couple seconds before you click again. It's going now.
Yeah, I was still talking there, I think. So, oh, maybe, oh, you know what? It was delayed for me. So, okay. All right. So this is our erosion control application. So in this particular case, you'll usually reprofile the soil, basically, get rid of debris, smooth it out, put down your matting, and then you'll come in with a small hammer. Usually can be gas powered, or we like small electric hammers a little bit better. Drive your anchor, put your plate and your wedge grip on, and then your device that you're going to use to load that anchor. We call this our SJ5. You can do this by hand. You can do it. There's another product called the Jack Jaw that is available. You can buy them on the internet. And then you might also use a hydraulic jack to load these. But most of the time for erosion control, you're not really measuring the loads. All you're doing is just tying down that mat permanently and mechanically. All right, so here you have a typical type erosion control application. This one's over in the UK. Nice little project. I always think that the US is so much far advanced and, from an engineering standpoint than other parts of the world. And while I think we probably come up with a lot of the standards, like using an erosion control blanket, they actually did a pretty nice job on this project, as you'll see here. And I guess we're leaders, but they're not dummies either. So here you can see they're using a temporary mat with a twisted wire over the top of it. In this particular case, this is an S6 anchor. So this anchor is about 7 inches long, maybe an inch and maybe 2.5 inches wide, or so 3 inches wide. And it can take up to a 1-ton load. So somewhere around 2,200 pounds on an application like you're seeing here. The anchor itself, you could load up, to 2 tons or even probably 2.5 tons. But here you can see the setup with this mini excavator. That hammer that's on there, that size hammer will drive even our largest anchor. So here they're using it for an S6. He'll pull the lever on that hammer to activate it, and that anchor will be driven in probably 7 or 8 seconds, if that. Then he'll pull the drive steel and they'll come in and put their tensioning device on and load that anchor up, and then snip off the leftover tendon and take care of that. Look at those anchor trenches. Nice job. In my 30 years of experience, the biggest challenge I always had was getting the contractor to actually construct those anchor trenches and put them in correctly. So whenever I've been in and out of erosion control for years, when I was out of it, whenever I'd see an application and somebody wasn't using trenches, I'd usually go over there and make a big fuss over it. And some people would listen and some would tell me to go somewhere else.
So some people, in my experience, don't want to do the trenches, so they think if they use enough anchors, they could forego the trench.
Yeah, I disagree. I still don't like that double row of staples. I still believe the best way to handle your project is with anchor trenches, because it cuts off any of the water that could get underneath those mats. And
Thank you.
I know that experience. I put my first TRM in probably 93 or 94. And I've used the anchor trenches ever since, and they've never been a problem. Where they don't use anchor trenches, they do have some problems.
Thank you.
Yeah, my 2 cents. All right, so now we'll look at some slope stabilization. Are you guys seeing this animation now?
Yeah, it's rolling.
Okay, good. So we're going to use a little larger hammer here, not so much a handheld 40-pound or 30-pound gas-powered. This would be more like your pneumatic hammer, or even a hydraulic hammer. We're driving this one, you know, that's probably 5 to 6 foot deep. You're going to remove that drive steel, as we've shown you in all these animations. You're going to put your load plate on. In this particular case, this setup that he's illustrating is actually for a 2-ton system. So he's got a 6-millimeter wire on there with 2 wedge grips. He's got the wedge grip on top of that piston or that ram. That's going to actually hold the load. And that bottom wedge grip, they're going to lock that thing down as soon as they get load. So that's why that jack that you see there has the legs on it, so that you have access to that lower wedge grip so you can lock against that load plate. So with that, there's also a load gauge on that. The one that we showed you here has a hand pump. We also do one with an electric pump, so it goes even quicker. But again, what we're looking at is slope stability here. So here's a project in Chapel Hill, North Carolina. This was done last year, in fact, early in the summer. And what they had here, this was a large housing complex where they had a pretty good sized cut, as you can see. And because of some water issues, they had some slides and slumping, as you can see here. Now, this particular engineer is one that's been using percussion-driven anchors maybe for 7 or 8 years, maybe even 10 years, but we don't do his designs. We'll review him every now and then. He'll bring us some stuff, but he does his own designs. What he came up here with was an S6 anchor on, I think he was putting about 2,500 pounds on these anchors, driven 10 to 11 foot deep on what he called a 4-foot pattern. Now, he used a 4-foot vertical pattern. When I say 4-foot pattern, that's typically plan view or down the slope. But we still got a little bit of work to do with Steve on some of his designs. He always shows that 4-foot elevation change rather than 4 foot on the mat itself. But as you'll see here, they went in and reprofiled this slope, tracked it the correct way as we know you're supposed to do. They used Anchomat R45 on this particular project. The reason why they like that particular product is it's got a grid built into it. So it spreads the load of that anchor, and it also facilitates hydraulic filling. So bringing another technology into our solutions that we provide is some of you have probably heard of the Green Armor system, where you spray Flexterra into the matting. We don't care if it's Flexterra, we'll use a BFM or whatever, but that's just a really good sound solution that works really good. And as you can see here, that's what they did.
And we've got a lot of options, but Flexterra is awesome.
Sure. This particular contractor actually built a rig too, so he doesn't have to lug around a big 90-pound hammer. So he's got a winch on this thing. He's got wheels on it. He's got a hydraulic power pack on here, and basically it's on a slide, and all he does is pull levers. Now, it won't necessarily allow him to drive more than 4 feet at a time, but he's not holding a hammer up over his head either. And you can see the vegetation that grew in later that summer. All right, I'm going to take you over to Switzerland. This is a beautiful project. I wanted to use one of our local projects for a very similar type application, but I think their photography was way better than ours. So I left this one in. This is a 45-foot cut that was pretty much an emergency type repair. They made the cut and then figured out that slope wasn't stable enough. So what they came up with was anchors coming down that slope at a very actually deep. They were, I think these were driven like 33, 35 feet deep. And you can see from the load here, this is in kilonewtons. This is 90 kilonewtons, which equates out to about 21,000 pounds or so. So that's pretty much, that's on the higher end of what we'll typically see. We see a lot of 1 ton, 2 ton, 4 tons for these type of applications. But this particular one, they did not drive those deep anchors with a handheld hammer. This is on the lower portion where they only had to drive them in. I think it was just a few meters. I want to say it was 2 or 3 meters, so 6 to 10 feet, something like that. And with a lighter load too at the bottom. But it was just part of their design. So as you can see, really neat project. They vegetated this one too. I have no idea what technology they used, if they sprayed into it or seeded it first. But again, just a great little project spotlight. So here you go. This is a steeper cut. This is when we get into some of our top-down construction. This would be for a temp wall or a permanent wall, even where they're going to put some type of facade over the face of it. Here you're going to see a multi-sectional drive steel. So now they're going to add another section. Each of those sections is, depending on the anchor and the depth, is either 4 or 5 foot per section. Now they're going to remove that drive steel just like they always do. And they're going to put their plate and wedge grip on, and then their jack again, using 2 wedge grips, one on top. That's sacrificial on top. They're going to reuse that one. They'll break that wedge loose with a hammer and a wedge splitter. Then they'll move over and do the rest of the anchors. On these top-down projects, you cannot excavate more than you can stabilize. So we'll have you do the entire row of anchors, and then you'll do your second row of anchors. You'll load them, get them locked in, and then go down and do your third row. This is an extremely economical way for stabilizing versus, say, sheet piling versus concrete versus timber lag. Here's a project. This is the same engineer that did the Chapel Hill project. This is a Boys and Girls Club near Asheville, North Carolina. These 2 buildings, you see the one on the right with the blue reveal up on top, and then you got the one on the left, the larger building. What they decided is they needed to construct a corridor in between those, but about 10 feet below the foundation of the larger building on the left. And so what they needed to do was basically shore up the building on the left while they excavated down to put the footers in and basically build the foundation and sidewalls for this building going in between these 2. So again, mentioned this is that same engineer that's been using the Platipus Anchors for some time. He came up with a 3-row design. This was our B4 anchor, and the loads on this were about, I want to say they were like 5,000 to 6,000 pounds per anchor. Spacing, I don't remember if it was 4 foot, or I think he might even had to tighten it up in some of the areas vertically and then spread them out horizontally. But this is what it looks like. You know, it's not beautiful all the time, but it is very effective. What we found is these walls in place, construction, materials, shipping, and built in place for the whole thing usually run somewhere between, say, $25 to $35 a square foot of wall. And that's going to be a fraction of using soil nails, a fraction of using sheet piling or some other type of lagging and timber. This is my favorite project here. This was New York DOT that we did 2 years ago. Project came in late in 2019, literally like after Thanksgiving. And within about 2 weeks, design was accepted. There was a design build by the contractor, CCA Contracting out of New York. And what they were doing here was widening the lanes on this expressway. So they needed to build a new MSE wall to accommodate the new lanes that were going in. So to build the MSE wall, they had to stabilize the current lanes so that they could keep the highway open while they built the new lanes. Same kind of construction that we just saw. It was top down. Here's the engineer's design. He went 14 foot deep with a B4 anchor on 5/8 inch rod. This was all temporary, so he used black steel, which might last 3 or 4 or 5 years in the ground. After they built the MSE wall in front of it, it really didn't matter. Got some really good pictures from this project. You can see here the initial anchors they were putting in. They did their excavation. They lined up their excavator with their pneumatic hammer on it, and they built this little jig down here at the bottom to hold the anchor on the correct angle. I got to start clicking a little bit sooner here. And then they
about 5 minutes left.
Yeah. So they put the load jack on. In this case, you can see rather than a wedge grip, they actually used a load nut, and a little bit easier to use. You can certainly break it apart easier. But again, they have a gauge on there telling them when they hit their 6,500 pounds or whatever that number was. Here you can see starting the second row. So they excavated down a little bit further, put all their anchors in, then they load them up, lock them off against these timber soldiers. And again, this has always been one of my favorite jobs. The other nice thing about it, again, this thing came in late October, mid-November or so, and then we were shipping materials by the 1st of January. We ended up selling about $200,000 worth of anchors on this project. I know that the contractor probably, I'm going to guess he saved $1 million or so doing this. So. All right, so one more. This was also in New York area. This one's on the New Jersey side. What we were dealing with here is another 45-foot deep cut where they needed, this was for a wastewater treatment plant. They needed to excavate down and shore up as they excavate down. They came up with, well, we gave them a 1-ton system. Their engineer looked at it and decided he wanted to up that a little bit. So he went up to 2,600 pounds. We basically just had to go to a little larger wire tendon to support it. Same anchor head was used. That 2,600 pounds that you see written on in marker on the load plate, that's the working load that they actually were required to load to. In this particular case, they did not use a welded wire. You can see they actually use a twisted wire, like a gabion type wire that has a built-in matting right into it. So they didn't even use a geotextile behind here. But a great little project. I think I got one other slide that shows you the full construction of it, 45-foot deep, looking straight down with a drone after they built up to, they're probably at 35, 40 feet at that point. So we get a lot of questions that say, well, how deep can I put these? How deep, how tall of a wall can I build? And really there's no limit on the wall. We might have you batter it about 10 degrees back. So you can't go 100% vertical, but we do 8-foot walls and we do 70-foot walls. It just depends on what's required. Here you can say, I really want to show you these next pictures. Same type of construction. This is for an existing wall going in to tie it back to do some repairs. It's all done the same way. They'll usually spend about maybe 4 or 5 minutes driving the anchor and another 4 or 5 minutes loading it. We conservatively will usually say you can do 3 to 4 anchors like this an hour with a 3-man crew and a guy on an operator on the machine. In reality, a lot of times the contractor, he'll figure it out. He'll do 3 or 4 an hour for maybe the first 6 anchors, and then he'll figure out, you know, to go a little quicker, and they might even get it up to 6 to 8, sometimes 10 an hour. This is another neat little project in the UK where this wall, who knows over there, this wall could be 300 or 400 years old. They do a lot of restorations over there like this. Our UK division probably has 25 case studies, spotlights similar to this. This is a great picture because here you can see them driving the anchor, so you can see what the hammer looks like. That's a lightweight hammer driving I think those are S8 anchors. I can't see the bottom of our page here, but you can see the drive steel. You can see the shank adapter that goes from the hammer point to the drive steel. That's one way to do it. And then closer up to us with the yellow legs, you can see the loading process in full action there. They use these concrete soldiers rather than a timber because this is permanent. A lot of times they'll use steel. This particular guy, I guess they figured out a way to strengthen their concrete to where they can use welded wire behind it with concrete, and then they'll build a new wall in front of it that looks like an old wall.
We're right at the 1 hour, Andy, but we don't have any Q&A here. So if you want to just finish up your slides, we'll
literally, there's just
go ahead
now, so there's only a few more. This particular one is just to show you different applications. Here's a sheet pile applications where they were required to tie back sheet pile. This was another New York DOT project, maybe 6 or 7 years ago. Tappan Zee Bridge project. You can see on that bottom right corner, you can see the anchor on the other side of the sheet pile. We also, some of the Rocky Mountain regions that I think you guys cross, you might get into some rockfall protection where they have to tie those down. A lot of times this isn't stability. This is just tie down of the matting itself. Then you can see a piling support. The anchors, you can see them maybe every 6 or 8 foot on center there. A lot of times they'll use soil nails on these. Again, percussion-driven earth anchor is good. We like to say 30 foot deep with a working load about 30,000 pounds. Whereas soil nails, a lot of times those guys will go 40, 45 feet deep, and they'll have 100 or 100 and even 120,000 pounds on those. So it's kind of a different animal. We're a niche where you don't need that much load. You don't need that special equipment to put it in. You don't have to mess with grout. You don't have to mess with the curing of the grout. You don't have to mess with a 24-hour test. Our anchors are immediately serviceable. You literally drive the anchor, you load it to that working load. There's no reason to hold on to that load to see what it's going to do. Once you build that cone of pressure, you're built, and it's holding you back. Another actually quite large industry we're in, we're pretty much the only manufacturer that has a percussion-driven earth anchor system for exposed membrane liners on landfills. And we had a project last year that had, man, how many did they have? I think it was about 50,000 of these on a project in New Orleans. And nice little project that came in right at the beginning of COVID. So where other people were gearing down, we were just gearing up. In fact, I don't even think they've installed them all yet, but they'll put these on a grid pattern too, usually say 10 to 15 foot. I mentioned buoyancy control earlier. This is actually a pretty pretty big business for us. You can see down in the right corner, you see the yellow strapping going over the pipes. Those have an anchor on either side of the pipe tied to that, not tied, but connected to that webbing. We make these in a 2-ton and a 10-ton kit. They're extremely economical. They're extremely easy to put in. It doesn't take any special equipment. You can get some very cheap insurance for your plastic pipe or even steel corrugated pipe for not a whole lot of money. A lot of times we'll have 2 or 3 kits per 20-foot stick. And then this is something I know ASP does a good bit. We've had the guys out of Bowman have had 2 or 3 of these projects. Cascade has one coming up. They've already bought the anchors from us, where they tie off for the GeoWeb style cellular confinement grid to keep that veneer on the slope. So the problem they get is a lot of times they'll put this on a steep slope, they'll load it up, and they'll find that over time that veneer wants to slide down the slope. So they've come up with a dead man pipe basically that they put in the ground up at the top of the slope. And a lot of times it's hard to construct. There's something else up there, either the shoulder of the road or a building or something where they can't put that pipe in. And you can drive an anchor straight down in those applications. Here you can see it's actually tied off. It's not a real highly engineered connection, but we do 3 or 4 or 5 of these a month. Very common.
And that tendon that's hanging down off that anchor has clips along there to hold each cell.
So that tendon, yeah, so it's actually that's what we call a rope grip or a cable clamp. And that cable clamp is so the contractor, once he installs that anchor, he can create the loop on top himself. So he'll put 3 of those in a row, which will, in the rigging industry says that if you have 3 cable clamps in a row, it equals the strength of your wire. So that's why we use 3. It's always stainless steel. We use, again, the grade 316 stainless steel tendon on those. And the reason why they want to create that loop in the field is because if we did it in the factory, you'd have loops at different elevations by the time you load that anchor. You might not drive at the same depth, or you might get more extension out of it when you go to load it. So here's a marine application. We're just about at the end of the presentation here. We do a lot of underwater anchors. Again, this is where our bronze aluminum comes in. Sometimes they're temporary, sometimes they're permanent. And just a quick summary, key benefits of using a percussion-driven earth anchor. They're simple and effective, lightweight, corrosion resistant, fast and easy, immediate quantifiable load. This is, again, as I mentioned, something that you don't get with a soil nail. They're not 100% loadable until you get, full curing of your grout. They're good for temporary and permanent, cost effective, no grout, low environmental impact, suitable for areas where you don't have much space.
I think you're there.
Yep. Yeah, so I don't know if you ever came up with any questions, but I'll turn it.
Oh, there's no Q&A, and I wasn't going to stop you there at the 1 hour. We had some people that had to get off at exactly the 1 hour mark. I was just going to let the attendees know that even though we didn't get a Q&A typed in here, we're going to send out a Survey Monkey to every attendee, and that's a really good opportunity when they answer that Survey Monkey to type in a question that they thought of. A lot of times we'll have a conversation with somebody and we come up with a better question later. So everybody, please keep an eye out on your email for that Survey Monkey. Please send that back. Thank you, Andy. Good job as always. I really dig your pictures and your stories. Always just wish we had more time with you. We have some upcoming webinars next Wednesday. We're going to keep going every Wednesday, so I'll fill in the rest of these dates. But Andy's readily available to do a presentation like this with your company. If you'd like, just make a mention of that in the comments, and we'll share your contact information with him as well.
Thank you all.
You bet. So thanks, Andy, and thanks everybody for attending, and I hope you all go on and have a great day. Thanks a lot.